Mean, the average mode, most often range. Subtract the smallest from the largest. Median, the middle number when you line them from the greatest to the least. Mean, the average mode, most often range. Subtract the smallest from the largest. Median, the middle number when.
Problem number 9 at the top of page 3 is a pretty straightforward problem, just checking to see whether you remember how to find the mean, median, mode, and range of a set of data. And the most important thing to remember, and the most common mistake usually made on a problem like this, is forgetting to order the numbers first. I mean, they're given to you in some random order. You need to order them from least to greatest. And you're hearing that song at the beginning and end of each video. So remember, median is the middle number once you line them up from least to greatest to least. So as long as we have to line them up for median, we might as well line them up for all the measurements, because median, mode, and range are all easier to find once the numbers are arranged from least to greatest. So my least number actually is 3.1. And as I place each one, I'm going to put a little dot over it so I know that I already used it. The next largest would be 3.2, 3 2/10, and then next would be 4 3/10. And then I have 4 5/10 occurring twice, so that's my mode, because it's the only data that occurs more than once. And finally 5 6/10. And to be extra thorough, I'm going to count 1, 2, 3, 4, 5, 6 numbers in my arranged data set, and 1, 2, 3, 4, 5, 6 numbers in my original data set, so I know I got them all. The mode jumped right out at us once we ordered them from least to greatest, and that's another reason to do that. The mode is 4.5. You can have more than one mode. We saw that on a previous problem. You could have one mode, that's most likely the case, and you can actually have no modes if none of the numbers occur more often than any of the others. The median is the middle number, and now that they're arranged from least to greatest, I could sort of underline a pair, a low and high pair, a low and high pair, and I see that I have 2 in the middle. But the middle of those two, 4.3 and 4.5, would be 4.4. You find the midpoint between those two middle numbers. It's the same as finding the average of those two middle numbers. I could take a tenth from 4.5 and give it to 4.3, and then they would both be 4.4, 4 4/10. So the median is 4 4/10. The range, subtract the smallest from the largest. So subtract 3.1 from 5.6, lining up my decimals so that my place values are lined up. 6/10 minus 1/10 is 5/10, and 5 wholes minus 3 wholes is 2 wholes. So 2 5/10 is the range. To find the mean, I have to add up all the numbers and then divide by how many numbers I have. We know we have 6 numbers, so I just need to find the sum of those numbers, and I'm going to choose number pairs that add together nicely, because, for example, 4.5 plus 4.5 is 9.0. Just add these. 3.1 and 3.2 is 6.3. And then these two that I haven't yet added, 4.3 and 5.6, that's 9.9. So now I have 6.3 plus 9 plus 9.9. 9 and 9.9 is 18.9. And 6.3 plus 18.9, lining up the decimals. 3 and 9 is 12, carry the 1. Line up a decimal in my sum. 8 and 6 is 14, and 1 is 15, carry the 1. 1 and 1 is 2, so I have 25 and 2/10 is my total sum of all the numbers. And then I'm dividing by 6 numbers. There are 4 6s in 25. 4 6s is 24. Subtract to get a difference of 1. I should line up this decimal in my quotient. Then I can bring down the 2, and there are exactly 2 6s in 12. So the mean is 4 2/10. The question below that says, if a number is added to the data set and the mean increases, what do you know about that number? Well, for the mean to increase above 4.2, you would have to add a number that is greater than 4.2. So the number is greater than 4.2. If the number that you added to the data set was exactly 4.2, then the mean would stay exactly 4.2. If the number you added was lower or less than 4.2, it would bring the average down. If the number is above 4.2, it brings the average up a little bit, or maybe a lot, depending on how big the number is. This final question asks, if a number is added to the data set and the mean decreases, but the range remains the same, what do you know about that number? Well, we said that if we added a number less than 4.2, the mean would decrease. But in order for the range to remain the same, we can't go any lower than this low number, because then the range, if we added some number to the data set that was lower than 3.1, that would increase the range. And so the number, I'm going to use n for the number, it would have to be, I'm trying to think of the best way to, it'd have to be less than 4.2 to decrease the mean, to lower the mean. But it would have to be greater than or equal to 3.1. Because if I went below, if I went anything less than 3.1, then the range would not remain the same. The range would change. So anyway you say that, as long as you say the number has to be greater than or equal to 3.1, but less than 4.2, then that's the correct answer. Problem number 10. Given that A is -2 and B is 3, compare these two quantities. So I'm going to substitute the values. A is -2 multiplied by 3 plus 5. -2 multiplied, we have to do the multiplication first, of course. We don't combine terms until we simplify each term. Remember, PEMDAS, multiplication and division, happens before addition and subtraction. So -2 multiplied by 3 is -6. And -6 plus 5 is -1. So the quantity in this box A is -1. Over here we have -2 multiplied by the sum of 3 and -2. Now in this case, I am going to find the sum before I multiply, because the sum is given in parentheses. I'm multiplying -2 by this sum. And so 3 plus -2 is 1. So I have -2, I'm going to bring it down here, -2 multiplied by this sum is 1. 3 plus -2 is 1. And -2 multiplied by 1 is -2, because negative multiplied by positive is negative. So the quantity in box A is -1, and the quantity in box B is -2. -2 is less than -1. -1 is greater than -2, so A is greater than B. Problem 11. Here again we're solving an equation. So I'm going to rewrite the equation. I have 1/5 multiplied by D is equal to -9. I don't want to know 1/5 D, I want to know 1D. And so I want to multiply 1/5 by its reciprocal, which is 5. If I multiply by 5, then these 5's will cancel, and I'll get 1D, which is what I want. But if I multiply the left side of the equation by 5, I need to multiply the right side of the equation by 5. That's property of equality to keep the equation balanced. -9 multiplied by 5 is -45. So D is -45. To verify, I'm going to use the substitution property and substitute -45 back into the original equation. 1/5 multiplied by -45 should equal -9. That's substitution. I'm going to do this computation on the side. 1/5 multiplied by -45 over 1. 5 and 45 have a common factor of 5. 5 divided by 5 is 1. 45 divided by 5 is 9. So when I divide by 5 here, I'll get -9. And so that equals -9 over 1, which is just -9. So -9 equals -9. I see the reflexive property here. The reflexive property is satisfied, so I've checked that D is in fact -45. The final problem on page 3, problem number 12. Dana has a summer job mowing lawns. The following amount represents her earning for mowing 5 lawns: $22, $25, $20, $18, and $25. Which measure is not represented by $22, the mean, median, or mode? To find the median, we're going to need to put these in order, so let's put them in order down here. 18, 20, 22, 25, 25. See, I have an odd number of, I have 5 data points in this set, and so the middle number is 22, so the median is 22. So it's not 22, it is 22, so the median is not the answer. The mode is 25, and that's not 22, so mode is actually the answer here. That must mean that the mean is 22. We should probably check that just to be sure. The sum of these, I have 50 here, if I add these two, plus another 42, plus 18. That's 10, carry the 1, that's 11. So 110 divided by 5 is 22. So the mean is 22. So it's not the mean, it's the mode. If Dana mowed 2 more lawns and earned $14 and $23, which measure would change the mean, median, or mode, and what would it change to? So I have the original data set, but now I'm going to add 2 more values. 14 is less than any of these, so I'm going to start with 14, 18, 20, 22, and this is where I'm going to put my 23 after the 22, 25, 25. The 25s are still the only number that are occurring more than once, so the mode is still 25, so the mode didn't change. The middle number, there's 3 on the high end, 3 on the low end, 22 is in the middle, so the median is 22, and it was before, so that didn't change. So the mean the mean must have changed. So we'll add these up. This is 50. These two added together are 45. And this is 38 and 14. Might be a more efficient way to do this, but I'll just do it this way. 13 plus 4 is 17, carry the 1. 5 and 4 is 9, and 1 is 10, and I've got 4 more, so 147 is the sum. You know what, I think I'm going to do this down here. 147 divided by, not 5 anymore, now I have 7 data points in my set. There are 2 7s and 14. Bring down the 7, and there's 1 7 and 7 with no remainder. So the mean changed to 21. Before the mean was 22, and now the mean is $21. So that's the one that changed, and that's what it changed to. That completes page 3. We'll conclude the review with the video for page 4. Thanks.
Median, the middle number when you line them from the greatest to the least. Mean, the average mode, most often range, subtract the smallest from the largest. Median, the middle number when you line them from the greatest to the least.